Okay, this is section 6.3, solving compound inequalities. When we finish, I want you to be able to solve a compound inequality as well as graph a compound inequality. And let's start off by talking about the OR statement. The OR statement implies that only one solution must be true to satisfy the sentence. So if I said I have brown hair or blue eyes, that would be true because my eyes are blue. And in this case, it happens to be true on both counts because my hair is also brown. If I said I have brown hair or green eyes, that statement's also true because my hair is brown. So only one part of my statement has to be true. So when we talk about an OR statement, it's going to be written as two different statements. When we graph it, these graphs are going to go outward. So you could have an open circle, shade outward for one part. You could possibly have a closed circle and shade outward for the other part. So in OR statement, the graphs are always going to go outward. Now let's talk about AND. AND implies that both statements must be true. Now an AND statement, or an AND inequality, can be written as one statement or two. We'll look more of that in a moment. Now when we graph an AND statement, you're going to have your two key points on the end. We could have an open circle and then a closed circle. And the area that's going to be filled in is going to be the area in the middle. Okay, now let's look at OR statements. Tell me numbers that are greater than 7 or less than 2. Well, numbers that are greater than 7. Well, that one's easy. 8, 9, 10, 11. So we're talking about numbers that are greater than 7. And it said or less than 2. So less than 2, that would be 1, 0, -1, -2. So this would be numbers less than 2. Now if I were to graph this, I'm graphing n is less than 2 or n is greater than 7. My two key points are going to be 2 and 7, so I have to make sure those guys are on my number line. Let's see, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Go 1 on the other side. Okay, so I've got a circle at 2 and it's open, an open circle at 7. Now numbers are less than 2. Oh, I've already told you what those are. Is 1 smaller than 2? Yes. So I'm going to be shading outward. Okay, n is greater than 7. Well, is 8 greater than 7? Yes. So I'm going again, once again, to shade outward. So this is just going to be the same thing. This one I have x is greater than or equal to 5 or x is less than 0. So I've got 0, -1. Put all my numbers in. My key points are 0 and 5. So at 0 I have an open circle. At 5 I have a closed circle. X is greater than or equal to 5. Is 6 greater than 5? Yes. So I'm going to shade to the right. Okay, is -1 less than 0? Oh, yes. So I'm going to shade to the left for this one. Now notice how my shading is outward and this area in between is just vacant. Okay, now these we're going to need to solve and graph. So I have 5x plus x is less than -4. I'm going to combine my like terms. So now I have 6x is less than negative 4. Divide both sides by 6. So I have x is less than negative 2/3. Now let's look at the other one. I'm going to add 2 to both sides. So now I have 6x is greater than or equal to 12. Divide both sides by 6. So I have x is greater than or equal to 2. So now my two key points are negative 2/3 and 2. So the first one, negative 2/3. Okay, I know that negative 2/3 is a little bit less than negative 1. So it should be right around there. I'm going to have an open circle. And I want to graph the areas where x is smaller. Negative 1 is smaller. I know looking at my graph, going to the left, those numbers get smaller. Now I'm going to graph x is greater than or equal to 2. So I'm going to go to 2. Greater than or equal to tells me I have a filled-in circle. And I want the numbers where x is larger, and my values get larger as I go to the right. Now, and statements. Now this one, I want you to tell me numbers that are less than 7 and greater than 2. Okay, numbers that are less than 7. So I've got numbers less than 7, 6, 5, 4, 3, 2, 1, and it just keeps on going. Now let's see, and greater than 2. Now what are numbers that are greater than 2? Well, 3. Oh, look, I have a 3 right here. I'm just going to write it under. 4, 5, 6, 7, and that keeps on going. So the area that I'm going to be graphing is going to be the area where these guys overlap, because they both have to be true. So when I write my statement, it could be written as x is less than 7. You could actually have the physical word and. X is greater than 2. So 7 and 2 are my key points. Those have to be on my graph. Okay, so now open circle at 7, open circle at 2. Now x is less than 7. Is 8 smaller than 7? No, so I know I'm going to be shading to the left. Oh, now I'm running into this too. So now let me check this one out. Let me get a different color. I'll get orange. Now it wants me to graph x is greater than 2. Well, is 1 larger than 2? No. Is 3? Yes. So this one, I'm going to shade to the right. And the solution is all this stuff in the middle. Because both things have to be true for my statement to be true. Now, and statements allow you a couple of ways to solve. One way you can do it is you can break it up into 2 problems, or you can just leave it as one whole one. This is another way to write an and statement without actually using the word and. So the first time I'm just going to leave it all together. So it's kind of like we're working with 2 equal sign, or so whatever we do to the middle, we have to do to this side and to this side. So we're going to have to do it to everything. So now we're going to add 5 to each side. So plus 5 plus 5. So now we have negative 4 is less than or equal to negative 4x, which is less than 8. Okay, I want to get this x all by himself, but he's going to stay in the middle. I'm going to divide by negative 4, divide by negative 4, divide by negative 4. I still have to change the direction of my inequality. So now this one's going to switch to greater than. This one's going to switch to greater than. I'm sorry, this one I should have said greater than or equal to. Negative 4 divided by negative 4 is 1. So 1 is greater than or equal to x, which is greater than negative 2. Now I have my key points. Okay, my key points are 1. 1 is greater than or equal to, so I'm going to have a closed circle at 1. And then at negative 2, I just have x is greater than negative 2, so I'm going to have an open circle at negative 2. Now if it helps, you can kind of cover up the x minus 2. So you're saying it's an and statement. So I know that the area that's going to be shaded is going to be the area that's in the middle. But sometimes if you're like me, you're going to want to see it in the pieces. So I can break this up and write it as two statements. I can write it as 1 is greater than or equal to x. Okay, now I don't want that x on that side, so I'm going to write it as x is less than or equal to 1. And then I also have and x is greater than negative 2. Now x is less than or equal to 1, so I know I'm going to be shading to the left because 0 is smaller. And x is larger than negative 2, so for that one I would shade to the right. So it is definitely the area that's in the middle. Okay, now this one I'm going to break into two pieces from the beginning. Now this is just going to be a personal choice. I want you to see both. I want you to try both and see which one you prefer. Because you can break it up into negative 3 is less than 2x plus 1. And so I took this half and made it into 1. Now I'm going to do the same thing, but I'm going to take it from this side. So I have 2x plus 1 is less than or equal to 7. So now I'm going to go through and solve these guys. Subtract 1 from both sides. So I have negative 4 is less than 2x. Divide by 2, divide by 2. So I have negative 2 is less than x, and let's do the other one. Subtract 1 from both sides. 2x is less than or equal to 6. Divide both sides by 2. So x is less than or equal to 3. Okay, so now that I'm looking at this, my 2 points are negative 2 and 3. Uh-oh. I didn't write that the way I was supposed to. I should have written that as x is greater than negative 2. And x is less than or equal to 3. So I'm going to have an open circle at negative 2. And I'm going to have a closed circle at 3 because I have less than or equal to. Now where is x smaller than 3? Going to the left. Now where is x bigger than negative 2? Oh, from that point it's going to be going to the right. So once again, the solution lies in the middle.